Hello students, AS level chemistry, chapter is chemical bonding, lecture number 3. In this lecture we are going to study what are ionic compounds, what are the properties of ionic compound, and strength of ionic bond, it depends on which factor, and finally I will tell you how to sketch structure of binary ionic compound. So this is the focus of this lecture. First of all, you must know what are ionic compound. Any compound that is made up of metals and non-metals, it is known as ionic compound. You can also remember any compound having an ionic bond, any compound having a bond between oppositely charged ions, it is known as ionic compound. So there can be many different ways by which you can give a description for an ionic compound. It is a force of attraction, it is a force of attraction between oppositely charged ions, that is known as ionic bond, and whenever this type of force is present in a compound, that compound can be known as ionic compound. Next thing, whenever you are asked to give a list of properties of ionic compound, you can remember there are 5 main properties of ionic compound. No need to remember detailed sentences for these properties. You can remember short phrases for the 5 properties of ionic compound. And what are these 5 properties that you must remember? First, let's make a list of these 5 properties, and then we will study detail of each one of these properties one by one. Okay, first of all, what you must remember, ionic compounds are hard solids. All the ionic compounds, they are hard solid. When they are hard solid, second and third property you can predict yourself based on this information. Anything that is hard solid, you can easily guess what would be its melting and boiling point. So they have high melting and boiling point. And any material that is having high melting and boiling point in chemistry, it is difficult to evaporate. And such materials that are difficult to evaporate, they are known as non-volatile. So remember, the first 3 properties of ionic compound, they are interlinked. If you just remember ionic compounds are hard solid, you can yourself write down the second and third property, that when they are hard solid, they would have high melting and boiling point, and they would be non-volatile. Now, in addition to these 3 properties, 2 more properties that are also very important for ionic compound. They are number 4, ionic compounds, they are electrolytes. They are electrolytes. And the last property that is most important for all the ionic compound, you must remember ionic compound, they do not have molecules. They don't exist as molecules. Rather, they have clusters of ions. They exist as a combination of positive and negative ions. So remember, whenever you see the word molecule somewhere, molecule is the feature of covalent compounds, covalent bonding. Ionic compound, they have no molecules. So these are the 5 properties that you can remember for ionic compound: hard solid, high melting and boiling point, non volatile, electrolytes, no molecules. Now if you are asked an explanation for each of these properties, what explanation you can remember? For the first 3 properties, same reason. You can remember why ionic compounds are hard solid, why they have high melting and boiling point, why they are non-volatile. Simple reason that you can remember: ionic compounds are hard solid, they have high melting and boiling point, they are non-volatile because they have strong ionic bond. They have strong forces of attraction between oppositely charged ions. So this is the simple reason why ionic compounds, they are hard solid, they have high melting and boiling point, and they are non-volatile. But again, next thing you must remember, do all the ionic compound have same strength of ionic bond? No. So we must remember that which ionic compound would have comparatively more strength and which ionic compound would have comparatively lesser strength. So for that purpose, you must remember strength of ionic bond, it depends on which factor. So remember, ionic bond strength, it depends on a factor. By keeping this information, this factor in your mind, you can guess easily. If you have been given two or more than two ionic compounds, if you apply this factor information, you can easily predict which ionic compound would have strong ionic bond. Let me give you first of all the explanation for this factor, then we will discuss two questions to apply this information. Remember, ionic bond strength, it always depends on charge density. Ionic bond strength, it always depends on charge density. What is charge density? Charge density, it is a ratio. It's a ratio of charge to radius. If we divide charge of an ion by its radius, that is known as charge density. Now, what is the relationship that you can remember between charge, radius and charge density? It is very simple relationship. You can remember this one word explanation for charge, radius and charge density. Simply remember, if the radius of an ion is small, charge is high. Now, numerator is high. So, what does this mean? The charge density of that ion would be high. And whenever ions of an ionic compound, they have high charge density, that ionic compound would have more ionic bond strength. So, this is the simple relationship that you must remember, that charge density, it is high when radius of an ion is small and charge is high, and when charge density is high, that ionic compound would have strong ionic bond, and whenever ionic bond strength is more, that compound would have comparatively high melting and boiling point, and it would be non volatile. I am giving you two different examples. Let's apply these factors and decide that in which case we will have strong ionic bond, or which compound would have high melting and boiling point. Look at the first example. If you have been given two compounds of sodium, sodium fluoride and sodium chloride. Now, before writing answer in your exam, you must make up your mind what is the charge density of ions of both these compounds. So, for that purpose, first of all, you will write down the charge, because charge is most important factor in deciding charge density. Why? Because charge is directly proportional to the charge density. If charge of two ions is identical, then you will consider radius, because radius is less important since it is having inverse relationship with the charge density. So, always remember, whenever you have been given two or more compound, first of all you must apply the idea of charge. If charge is identical, then go for the radius. If charge is different, you can make the conclusion the ion having high charge would have high charge density, it would have higher melting and boiling point, it would be more harder. Now, let's see this example. Just write down the charges: sodium 1 positive, F 1 negative, sodium 1 positive, Cl 1 negative. Now, one thing you can notice in both these compounds, sodium ion is a common ion. Whenever common ions are present, they cannot play any role in deciding the strength of ionic bond, in deciding the melting and boiling point. So, which ions normally matter? Those ions which are different. Right now, one compound is having fluoride ion, other compound is having chloride ion. Now, if you start with the charge, what you can see, both fluoride and chloride, they are having same charge. Now, when they are having same charge, now we will move on to radius. Now, radius of fluoride and chloride ion, either you can get this from the data booklet, or you can decide radius from the periodic table. How you can decide the radius from the periodic table? An element with lesser atomic number has small radius. If you look at the periodic table, the atomic number of fluorine is 9, while the atomic number of chlorine is 17. So, what does this mean? It means fluoride ion, it is small in radius. Now, you have made up your mind. Now, you can write down the answer. If the question is which one of these two compound is more harder, which one of these two compound is having strong ionic bond, which one of these two compound is having high melting and boiling point, what will be your answer? Sodium fluoride. Next you will write down, because sodium fluoride has strong ionic bond. Why? Because fluoride has high charge density. Why it has high charge density? Because fluoride, it is small in radius. Now you can see in this answer, I have not given any indication about the charge. Whenever a factor is common in the given compound, no need to mention that factor. So simply you can exclude that factor. So the straightforward answer that you should write down, sodium fluoride has high melting and boiling point since it has strong ionic bond, as fluoride has high charge density due to small radius. One more question, I am giving you a set of two compounds, just decide which one would be more harder. Write down, you can pause the video and you can write down the answer. The compounds are sodium oxide and magnesium oxide. Write down answer on your notebook, which one of these two compounds would have higher melting and boiling point. Okay students, if you have decided, if you have written or you have decided mentally that which one of these two compound is having high melting and boiling point, I am going to tell you. First of all, make up your mind by writing charges on these ions. Sodium 1 positive, oxygen 2 negative, Mg2 positive, oxygen 2 negative. So you can ignore which ion in this case, you can ignore the common ion, oxide ion in this case. Now just look at the charge of sodium, it is 1 positive, and the charge of magnesium, it is 2 positive. Now what does this mean? Which ion is having high charge density? Magnesium. Why? Because it is having high charge. No need to look at the radius, because charge is more dominating factor, charge is more decisive factor. So you can say magnesium has high charge density, that is why what will be your answer? Magnesium oxide would have high melting and boiling point. Magnesium oxide would be more harder solid. Why? It has strong ionic bond. Why? Magnesium ion has high charge density due to its high charge. That's it. So this is how you must know. This question can be asked both in your AS as well as in your A2 exams. You must remember, strength of an ionic bond, it depends on charge density, and charge density is controlled by ionic charge and ionic radius. Ionic charge is more important factor, but if charge is identical, then we look at the radius. Okay, these are the reasons for giving an explanation for hard solid, high melting and boiling point, non-volatile nature of ionic compound. Moving on, what information you must remember about the electrolytic nature of ionic compound? One thing you must know, what is an electrolyte? Whenever you are asked define electrolyte, remember that there are two important pieces of information that you must mention while writing the definition of an electrolyte. What is an electrolyte? Any chemical substance that can produce ionic solution when dissolved in water. One information you must write down, any substance that can produce ionic solution, it is an electrolyte. And second condition, that must be able to show conduction. Ionic solution must be able to show conduction. Okay, so you must remember, electrolyte is a chemical substance that can produce ionic solution in water and that can show conduction. Also you must remember, generally electrolytes can be of two different types. One type of electrolytes, we call them strong electrolyte based on solubility. This classification is based on solubility or based on ionization. What is a strong electrolyte? Any electrolyte that ionizes fully, it is known as strong electrolyte, or that dissolves completely, it is strong electrolyte. And any electrolyte that ionizes partially, that ionizes sparingly, or that dissolves partially, it is known as weak electrolyte. So you must remember that electrolytes, what is an electrolyte and what are the two types of electrolyte: strong electrolyte and weak electrolyte. Next thing, you must remember what is conduction, and in chemistry conduction depends on how many features. Okay, first thing you must remember, what is conduction? Conduction is the ability to flow charge, ability of a chemical substance to show flow of charge, it is known as conduction. And in chemistry, there are three important features that decides about the conduction of a material. Sometimes conduction of a chemical material depends on presence of mobile electrons. If a material is having mobile electron, it can show conduction. If a material is having mobile ions, it can show conduction. If a material is showing vibration of atoms, it can show conduction. So in chemistry, there are three important features that you must remember both for your AS level and A2 level. Conduction is the ability to flow charge, and conduction of chemical material can be due to the presence of mobile electrons, mobile ions, and vibration of atoms. Now I can give you one example in each case that you can remember. Which chemical material can show conduction due to the presence of mobile electron? All the metals. All the metals, they can show conduction due to the presence of mobile electron. And also there is a non-metal. Non-metal is carbon, and carbon in the form of graphite. Graphite is an allotrope of carbon that can show conduction due to the presence of mobile electron. So you must remember metals and only one non-metal, carbon, they can show conduction due to the presence of mobile electrons. Which material can show conduction due to the presence of mobile ions? One type of compounds are ionic compounds that we are studying, and the second type of compounds are polar covalent compounds. What are polar covalent compounds? This we will discuss in some next lecture. Right now, just remember covalent compound can be either polar or non-polar, and only which type of covalent compound can have mobile ions? Polar covalent compound when they are dissolved in water. Vibration of atoms. Which material can show conduction due to vibration of atoms? Semiconductor. Examples of semiconductor that you can remember: silicon and germanium. Metalloid. What is a metalloid? That can show the characters of both metals and non-metals. It is known as metalloid. So you must remember in chemistry, conduction, it depends on three features: presence of mobile electrons, presence of mobile ions, and vibration of atoms. Now we are studying ionic compound, and you have come to know ionic compound can be conductor. They can show conduction due to which feature? Due to the presence of mobile ions. But remember, whenever you have been given ionic compound can be given in three different forms. Ionic compound can be given in three different forms. Number one, ionic compound can be in solid form, it can be in molten form, it can be in solution form. What is molten form? If we heat a solid, when on heating a solid turns into a liquid, that heated form, that liquid form of a solid obtained through heating, it is known as molten form. So ionic compound, they are conductor only when they are in the molten form and solution form. Why? Simple reason you can remember, because in the molten form and solution form, ionic compounds have mobile ions, but in the solid form, ionic compounds are non-conductor. Why? Because ions are not able to move, there are no mobile ions. So this simple information you must remember to answer different style of questions in your exams. So right now you can see we have discussed four important properties of ionic compound. You must remember that first three properties, they depend on ionic bond strength, and ionic bond strength depends on charge density, while electrolytes, they give the ability to an ionic compound to show conduction due to the presence of mobile ions. Next come the last thing, that is very important. You must remember ionic compound, they have no molecules. Rather, ionic compounds, how they exist as, they are a combination of ions. They are a cluster of ions. What name we give to this cluster of ions of an ionic compound? You must remember this combination is given the name of cubic crystal lattice structure. So ionic compound, they have giant or crystal lattice structure. And you must remember what is a lattice. lattice structure is the name given to a 3D, three-dimensional arrangement of atoms, ions or molecules. In chemistry, 3D arrangement of atoms, three-dimensional. What are the three dimensions? X-axis, Y-axis and Z-axis. The three-dimensional arrangement of atoms, molecules or ions. In chemistry, this 3D arrangement is known as lattice structure. And in chemistry, we have four types of lattice structure. There can be four types of lattice structure that you must remember. Question can be set in your exams. Four types of lattice structure. One type of lattice structure I have already told you, ionic crystal lattice structure. You can remember the example of any ionic compound. Other type of lattice structure is simple molecular lattice structure. Now what I told you, whenever you see the word molecule somewhere, it means which type of bonding that substance would have. Covalent bonding. Molecule is the feature of covalent compound, covalent bond. And if there are no molecules, it is obvious there in that substance there would be ionic bond, because ionic compound have no molecules, covalent compound, covalent substances, they have molecules. Third type of lattice structure, it is known as macromolecular lattice structure, giant lattice structure. And the fourth type is metallic lattice structure. You can remember one or two examples in each of these four cases. Commonly, any ionic compound you can remember: NaCl, Mg, O. Simple molecular lattice structure, you can remember the example of simple diatomic molecule I2, iodine, octaatomic sulfur, acid, tetraatomic phosphorus, P4. Macromolecular compound, you can remember sand, silicon dioxide, silica, SiO2 and silicon carbide. You can also give the example of diamond and graphite as macromolecular lattice structure, but remember diamond and graphite, they are not compounds, they are elemental macromolecular lattice structures. And in metallic lattice structure, you can remember the examples of any metal like sodium, zinc, copper, iron, etc. Okay, these are the four types of lattice structure that you must remember, can be asked in your exams. Okay, next thing that you must remember, commonly, not always, commonly, the crystal lattice structure of ionic compound, it is cubic. What is a cube? Cube is a figure that has six equal sides. Any figure that has six equal sides, it is known as a cube. Look at the diagram. I am going to sketch cube in front of you. Draw a square, another square above this. Now we have drawn two squares. When we connect the corners of these two squares, what we will get? We will get a cube. Now you can see this figure is having six equal sides. Left and right hand sides are equal, top and bottom they are equal, front and back they are equal. So cube is any figure having six equal sides. Now since we are going to sketch crystal lattice structure of an ionic compound, and you people know very well ionic compound, they are combination of positive and negative ions. Let's suppose we represent positive and negative ion with the help of different colors. Positive ion, you can see we have shown with the help of one type of color, and negative with the help of other type of color. Now what you must remember, whenever you want to show the placement of positive and negative ions, always remember oppositely charged ions attract each other. So if you place somewhere positive ion, now close to this only negative ions can exist. A negative ion cannot stay close to another negative ion, a positive ion cannot stay close to another positive ion. So on all the close by position, we will place negative ion for this positive ion. Now next to this negative ion, now you will place positive ion, and next you will place again a negative ion. Now what you can see, this is the smallest possible repetitive structure of any ionic compound having cubic crystal lattice structure. This is the smallest possible repetitive structure of an ionic compound. This smallest possible repetitive structure of an ionic compound, it is known as unit cell. Smallest repetitive structure of an ionic compound, it is known as unit cell. What you must remember, in a unit cell, what is the number of ions that can exist? In a simplest unit cell, 8 ions can exist. You can see there are 4 positive ions and 4 negative ions. This structure is known as cube. Next thing, based on this cube, you can draw this cube in the exam whenever you are asked to sketch the cubic crystal lattice structure. But I can also tell you another style of sketching cubic crystal lattice structure. What is the important feature for most of the binary ionic compound that you must remember? What is binary ionic compound? Binary means made up of two elements, not two atoms. Binary means made up of two different elements, at least two different elements must be present. For example, NaCl, it is a binary compound. MgO, it is a binary compound. Al2O3, it is also a binary compound. No doubt, number of atoms are different in aluminum oxide, but it is a binary because binary nature is associated with number of different elements, not number of different types of atoms. So you can see in all these three examples that I have written in front of you, these three ionic compounds are binary ionic compound and they have same type of cubic crystal lattice structure. Mostly, not always, mostly you must remember ionic compound, they have same type of cubic crystal lattice structure. And what is the important feature of a cubic crystal lattice structure? In a cubic crystal lattice structure, mostly each positive ion is surrounded by 6 negative ions. Each positive ion is surrounded by 6 negative ions and each negative ion is surrounded by 6 positive ions. So you must remember now how to sketch the cubic crystal lattice structure. I am going to give you example for two of these three compounds. Suppose we start with NaCl. This is one positive ion. On its 6 sides there must be negative chloride ion. Right side, left side, up, down, front, back. But you know it is difficult whenever we are drawing some line in and out of the whiteboard, it is difficult. So how we represent a line in and out of the whiteboard? Simply using a tilt or slanting line. And remember, tilt or slanting line, it must have lesser length compared to the other two axes so that it can give a it can give an appropriate look. Now what you can do, at the ends of all these 6 lines you can place negative ion and you can see each positive ion, it is surrounded by 6 negative ions. Remember, this property of an ionic compound is known as coordination number. Coordination number means number of negative ions surrounding a positive ion is known as coordination number. What is the coordination number? In this case you can see 6. Likewise, coordination number for chloride is also 6. It is also surrounded by 6 sodium ions. Right side, up, down, front, back. Each chloride surrounded by 6 sodium ion. Now you can see this is the cubic crystal lattice structure, but again I am telling you, cubic crystal lattice structure, each positive ion is surrounded by 6 negative and each negative ion is surrounded by 6 positive. But there are some exceptions, just we are not considering exceptions right now. Just remember, whenever you are asked a question in AS level, you are supposed to draw 6 negative around a positive and 6 positive around a negative. Okay, you can pause the video, you can sketch the lattice structure for MgO and Al2O3. Don't be confused that there are 2 aluminum and 3 oxygen. It makes no difference. One aluminum ion will be surrounded by 6 oxide ion, and one oxide ion will be surrounded by 6 aluminum ion. That's it. The number of ions remains same. Only you must remember in your mind that aluminum and oxide and magnesium, they have different charges. Magnesium has a charge of 2 positive, aluminum 3 positive, O2 negative. Okay students, now if you have sketched, I can show you the lattice structure of aluminum oxide. Likewise you can sketch for magnesium oxide. Okay, you will place aluminum ion, Al3 plus, right side, left side, up, down, back, front. Now you will place which ion at the end of all these oxide ion. Now you can see one aluminum, it is surrounded by 6 oxide ion. Now likewise, choose the oxide that is present on the right hand side, place 6 lines, right side, up, down, back, front. Now these positions will be occupied by aluminum ion. So this is a simple way to sketch cubic crystal lattice structure of binary ionic compound. Whenever in your A levels exams you are asked to sketch binary, you are asked to sketch cubic crystal lattice structure for binary ionic compound, you are supposed to sketch this diagram. Now you can say that what about the unit cell? In the unit cell you cannot see the coordination number 6, and what if someone is interested to draw that cube as a structure in the exam? Okay, no problem, you can draw that unit cell in the exam as an answer to the cubic crystal lattice structure, even that is acceptable. But what you must do after drawing this unit cell that is in front of you, just look at any one corner. I am looking at this corner, this is the positive ion, there is an ion on its left hand side, so you will place a negative ion that on the right hand side also. There is a negative ion on the lower side, you will place another negative ion on the top. There is negative ion outwards, you will place a negative ion inward. Now place these ions, negative ions. Now look at, with respect to this positive ion, it is surrounded by how many negative ions? 6. So it doesn't make any difference whether you draw simple structure, the two types of structures I have drawn below, or you can draw the cube, and any one corner of the cube you can use to show that each positive ion is surrounded by 6 negative ion, or each negative ion is surrounded by 6 positive ion. I hope you would have enjoyed this lecture. If you have any question related to this, you can give your feedback in the comments. I would try to give answer to your questions as soon as possible. Thank you for your time. Bye.